Good morning. This is Dr. Yogesh Agrawal, Associate Professor, Sagar Institute of Research and Technology, Bhopal. Today I will discuss about the binary vapor cycle. Before going on the main slide, today I will discuss about the outline, introduction of the binary vapor power cycle, fluid used, requirement for a good working fluid, advantage of the mercury vapor, disadvantage of the mercury vapor, calculation for the thermal efficiency. So this is the binary vapor cycle. Before starting of the binary vapor cycle, how we use the binary vapor cycle and why are the requirement for the binary vapor cycle? Because of the thermal efficiency of power plant is very low. To improve of the efficiency of the power plant, it can be used there two types of the fluid where it can be increase the efficiency of the thermal power plant where the working temperature of the higher than the simple vapor. It can be use of the mercury vapor in the power plant, which improve the efficiency of the power plant. A cycle work with the two working substance producing the dual work, but at only one heat supply, that is called a binary vapor power cycle. This is the main motive of the binary vapor cycle. The heat that is rejected in the condenser can be used to generate vapors of the some other working substance at a high pressure to run another Rankine cycle that produce the work. In a simple Rankine cycle, simple vapor which are using in the steam turbine to producing of the work in the turbine section, and after that power can be utilized in the alternator for the some other places. To run a binary vapor cycle, the two working fluids should have the high temperature differences. The substance having the high boiling point act as the working medium in the topping cycle and the other in the bottoming cycle. Topping cycle is consisting of the simple vapor, and the bottoming cycle it's consisting of the binary vapor, that is the mercury vapor. The water which are they using at the 12 bar saturation temperature, which is the 187 degrees centigrade, mercury which were used in the thermal power plant, it is 12 bar, and the saturation temperature is the 560 degrees centigrade. Diphenyl ether, that is the fluid we are used, aluminum bromide, that is we are used at the rate of 12 bar saturation temperature is the 482.5 degrees centigrade. Liquid metals like the sodium and the potassiums, they are used in the binary vapor cycle. Since the critical pressure and the temperature of the mercury are 1080 bar and the 1460 degrees centigrade respectively, it is suitable working fluid in the topping cycle. Requirement for a good working fluid, that is the large latent heat of vaporization. Critical temperature of should be well above the metallurgical limit so that the latent heat can be supplied at the maximum temperature. The condensation pressure should not be too low. The freezing point should be below the room temperature. Highest saturation temperature, low specific heat, high density, stripped saturated vapor line, higher saturation pressure than the atmospheric pressure, non-toxic, non-corrosive, and the non-exclusive viscous. These are the main requirement for the working fluid, and these working fluid are the working of the most of the large latent heat of the vaporization. It should be of the low specific heat because of the if the high specific is maintained, there will be chances of the bursting of the turbine section. High density, it should be required. What are the advantages of the mercury vapor? Moderate vapor pressure, which are the high temperature, 560 degree temperature. This is the above the critical temperature. The saturation pressure is the 12 bar. Higher thermal efficiency at the lowest pressure side, the highest temperature can be achieved when we are using the mercury vapor. Higher thermal efficiency can be achieved. A specific heat of the liquid is only 0.3144, so that the liquid line is steep, making the cycle closer to the carbon cycle. A specific enthalpy of the mercury vapor is low, thus the resulting in the lower jet velocities. Liquid mercury has a high density, which is the advantage in the separation of the liquid from the vapor in the boiler. What are the disadvantages of the mercury vapor? High cost and the limited supplies. These are the main disadvantages of the mercury vapor. Toxic in the nature. This is the another disadvantage. It does not wet the surface, which causes the poor heat transfer. This is the another disadvantage because of the it does not wetting of the surfaces which are connected with the number of parts. Latent heat is very low and the requiring the large amount of the mercury for the same heat addition, and the mercury is a very high cost. These are the arrangement mercury water binary vapor cycle, in which the first cycle, that is called the mercury vapor cycle, and second is called a steam turbine cycle. So there is a two type of the cycle in which the after the mercury which are the expanded in the turbine, or mercury vapor which are the expanded in the turbine, passes through the heat exchanger, where the heat exchanging it is taking place between of the steam vapor and the mercury vapor. Steam vapor it is prepared from the boiler sides, and the steam vapor these are the creating from the steam pump, which are the supplying of the liquid type of the steam vapor, and which are the increasing of the temperature and producing of the steam, which are utilizing in the superheater, and it increase the temperature and the pressure also in the superheater devices. After that, it is passes through the steam turbine, where it can be expanded into the lowest pressure, and after that it is busy passes to the condenser unit, where it will be condensed into the liquid form. So these are the cycle which we are used. Mercury cycle is the first cycle, steam cycle is the second cycle. So mercury cycle it is called a topping cycle, and the steam cycle that is called a bottoming cycle. The steam cycle we are using the superheated steam. It can be exchanging of the heat in the heat exchanger, and after the mercury which are the expanded mercury vapor which are the expanded in the turbine passes through the heat exchanger, where the heat can be utilized, and again where the mercury at the liquefied manner after the heat exchanging between of the two fluids, it can be recollected from the mercury pump, and it's supplied to the boiler, where it can be recirculated to the turbine. These are the cycle which are the repeated. So there is a TS diagram in which the mercury cycle and the steam cycle process are the explained clearly. 3 to 4 is the mercury vapor is expanded in the mercury turbine, and 4 to 1 that is the mercury condensed into the heat exchanger. 1 to 2 is the feeding of the mercury in the mercury pump, and 2 to 3 is the heat supplied. 3 7 to 8 that is the steam expansion, it is the taking place in the steam turbine. Superheated steam is still expanded in the steam turbine. 8 to 5 that is the condensation of the steam, it is taking in the condenser unit. 5 to 6 that is called pumping of the steam in the pump section. And there is a section where the mercury which are working at the above the critical temperature, it is represented in the topping cycle, and steam cycle which is working at the lowest temperature of the critical temperature, that is called the bottoming cycle, and it is represented below of the mercury cycle. This is the binary vapor power cycle. This is the two types of the turbine: high temperature turbine where the mercury vapor are utilized, low temperature turbine where the steam vapor are the utilized or the expanded in the turbine. There are the two pumps also. It is represented. First pump it is used for the mercury vapor. Second pump it is used for the steam vapor. Condenser unit after the expansion in the turbine section, it is passes through the condenser unit, where it will be condensed into the simply manner, and after that there is a chances of where the pump it is utilized for the using of the circulating of the mercury vapor again and again in the boiler section, which are represented in the diagram. And after that the low temperature turbine where the steam vapor it is expanded into the low pressure manner, condensed into the condensing unit, and the passing through the second turbine, and passing through again into the heat exchanger, where the heat exchanging of the mercury vapor and the steam vapor it is taking place, where the steam it is the formation take place and supplied to the another cycle. So this is the binary vapor cycle of the cycle diagram. Calculation for the thermal efficiency binary vapor cycle, the heat supply which are the represented by the formula Q1 is equal to the M of the mercury H2 minus of H1, which is the represented in the diagram. Total work done in the cycle, that is the mercury turbine work done, and the steam turbine work done, that is the MHG H2 minus of H3 plus steam turbine of mass H5 minus of H6. Thermal efficiency of the binary cycle, that is the net work done upon the heat supplied. So that is the net work done. Heat supply, that is mercury of the mass, that is represented here, and H2 minus of H1, that is the enthalpy difference of the heat supplied. Energy balance equation gives that is the mass of the mercury, that is the heat exchanging between of the two fluid are the taking place, that is the mercury vapor and the steam vapor, that is the S3 minus of H4 is the enthalpy differences, where the heat differences are represented by the enthalpy differences S3 minus of H4 into the mass of mercury equal to the mass of the steam into the bracket of H5 minus of H9. That is the enthalpy differences of, or the heat differences of the steam vapor side. The combined efficiency, that is the 1 minus of the in the bracket of 1 minus of the efficiency of the mercury upon into the multiplied of the 1 minus of the efficiency of the steam turbine. That is the calculation for the thermal efficiency. Thank you. This is the today topics. Tomorrow I will discuss the another topic of the power plant. Thank you.